All right, here we go with part 2 of the exam for review. We ran out of time in class today to finish the practice exam, so I'll be covering it now. So again, for posterity, this is the spring semester of 2024. And let's just get this thing started with problem 4. So finding the area of triangle ABC, given that we know side A, angle B, and angle C. So with the provided information, this is the beginning of a side angle side problem. So if we had to solve the whole triangle, we'd start with the law of cosines. But we only need the area, and as it turns out, we're given just enough information to calculate the area without needing to solve the rest of the triangle. One of those formulas for area that you can find on the formula sheet says that the area of a triangle is equal to 1/2 of C times A times the sine of angle B. So that is, again, one of those formulas that we have for area. It basically is 1/2 base times height, but rewritten to be in terms of A, B, and C. And all we've got to do is plug in the information we were given. So this will be 1/2 of 4 times 12 times the sine of, that is 81 degrees, which was B. B is in blue. And that's equal to a number. I'm also just gonna reposition this so it's into the middle of our box. I plugged that into a calculator and I got an answer of 23.7. Rounding this thing to 1 decimal place of accuracy as the question requested. Lastly, I should make sure that I put the appropriate units on here. I know I should be doing square units because it's an area. And my initial units were given in centimeters, so this thing should be in square centimeters. I'm actually gonna move some things around to make my answer look a little bit more clear. Square centimeters, that's an area. All right, let's take a look at the next one. Finding the exact value of whatever this is. Sine of 3 pi over 8. That's our goal here. So if you've seen some of the notes on the way that these answers come out, I'll just express its form over here on the right. All of the sine and cosines of the pi over 8 class of angle come out to something like plus or minus the square root of 2 plus or minus the square root of 2 all over 2. So they'll all have a form like this by the time it's done being simplified. And then there's a couple of plus or minuses that we need to resolve to figure out which one it is specifically. So I know that I should get my answer to be in this form, since if this were a multiple choice question on, say, the unproctored or out of recitation version of the exam, the multiple choice box would be filled with all possible permutations of that formula. So we've got to figure out which one we're looking at here. So let's take things back over to the one that we want. We're looking at the sine of 3 pi over 8. And as a quick reminder of how we're going to solve that thing out, 3 pi over 8 is half of 3 pi over 4. Go in blue. Since 8 is twice 4, and both numbers are in the denominator. So 3 pi over 8 is half of 3 pi over 4. So I'm going to go to a half angle formula for sine, which says that this thing should be, let's try again, plus or minus the square root of 1 minus the cosine of 3 pi over 4 all over 2. Well, that 2 is still on the inside of our square root. I should note. Squeeze that down so it fits inside nicely. So notice that the value, the cosine value, the angle that goes on the inside of the square root is something I know from the unit circle, but the outside of this square root depends on 3 pi over 8. So the inside, I need 3 pi over 4, but the outside to determine whether I've got that plus or minus that's hanging out there, which of those I want to choose, I need to decide which quadrant 3 pi over 8 is in. So I'll spoil the answer right now, say this thing's in quadrant 1. But here's how I'd check to see which quadrant it's in. I'm going to list out 0 to 2 in 1/2 increments. 0, 0.5, 1.0, 1.5, 2.0. And then draw a line in between each of those numbers. So these all represent 0, pi over 2, pi, 3 pi over 2, and 2 pi. I've just written out only the coefficient that's on pi. And to label these things a bit further, each of these lines represent the 4 quadrants. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So quadrant 1 is in between 0 and pi over 2, or between 0 pi and 0.5 times pi. Quadrant 2 is in between 0.5 times pi and 1 times pi, so on and so forth. I need to place 3/8 into one of these quadrants, in between 2 of these numbers. Goes along one of these lines that I drew in, and 3/8 as a decimal is about 3.75 or 0.375. 3/8 goes right here, in between 0 and 0.5, meaning that 3 pi over 8 is in the first quadrant. So I know my 3 pi over 8 is in quadrant 1. So out of my plus or minus choice here at the top, I'm going to choose the positive one. So if I start trying to work this all out, I'm looking at positive the square root of 1 minus cosine 3 pi over 4, which is negative root 2 over 2, all over 2. And then I need to start simplifying this thing out. I've got too many denominators, so I'm going to multiply top and bottom by 2 in order to get rid of an extra denominator. So then I'm just looking at the square root of 2 plus the square root of 2 all over 4. And then the denominator simplifies to just 2, since 4 is a square number. So I've got the square root of 2 plus the square root of 2 all over 2. So I had the positive values on both of the plus or minuses from that form that we were using at the beginning. But again, if this were a, possibly a multiple choice question that you'd run into on the out of recitation version of the exam, you could expect to see all 4 permutations of that formula there on the upper right part of the screen, and you'll just have to simplify down to the correct one. All right, next up, we're going to solve a trig equation. So I've got the cosine of 2 theta is equal to cosine theta minus 1, and I want to solve this thing for theta. So what I'd like to do here with these trig equations is usually get everything in terms of just one trig function would be nice. But also it's important that all of my angles match up. Because I can't really do much with the other identities that we have unless our angles all are the same. While they both contain theta, one of them is 2 theta, where the other one is just theta itself, cosine of 2 theta versus cosine of 1 theta. So I want to use as my first substitution, as my first identity substitution here, something that'll replace cosine 2 theta. And we know one of those from the double angle formula. So we can check that over on our formula sheet. Cosine of 2 theta is equal to 3 different options. But I'm going to choose the one that only relies on cosine theta since my right side already has cosine theta in it. So I'm going to call this thing 2 cosine squared of theta minus 1. And again, that's the double angle formula for cosine that I'm just substituting in. And it's equal to cosine theta minus 1 on the right side. That part won't be changing just yet. But now I'm going to get everything on one side, have it equal to 0, and then probably factor and solve. So if I bring everything over to the right side, I'll still be looking at a 2 cosine squared of theta, but I'll also subtract over a cosine of theta. But now I've got a minus 1 on the left, and I need to add 1 from the right. Those both add up to 0. The minus 1 on both sides just equal to 0. Now, looking at that left side, it's going to factor. I can pull a cosine of theta out and be left with 2 cosine theta minus 1. Again, still equal to 0. Line that up so my equal signs, I'll go down a straight line. And now I've got 2 things that multiply together to get 0, which must mean that one of those 2 must itself be 0. So either 2 cosine theta minus 1 equals 0, or cosine theta itself is 0. Keep that from running off the edge of the screen. And then start solving these. The right equation is already pretty good. I'm ready to solve that one. The left side, I still need to get it in terms of just cosine theta. And if I add 1 to the other side, divide both sides by 2, I'll get 1/2. So 2 options for cosine, and I need to pick out all of the angles that work for those 2. So from cosine theta equals 1/2, I know that happens at 2 locations on the unit circle. We switch back over to green. First one's at pi over 3, because it's in the first quadrant where cosine's positive. The other one will be 5 pi over 3 from quadrant 4, where cosine's positive again. Then for the other side, the answer highlighted in blue, I've got cosine theta equals 0, and that just happens twice. First at pi over 2, and then again at 3 pi over 2. The 2 angles that are on the y-axis. Cool. And then those 5 angles are solutions to the original equation. Any one of those would solve that thing. All right, and then let's look at another one. Problem 7. I've starred this one because I think it's one of the ones you'll want to pay attention to for the exam that is in recitation on Thursday. So if you're watching this still Wednesday night, then yeah, it's the one that's tomorrow. If you're watching it Thursday morning, go get to recitation because I'm sure it starts soon. Anyway, I digress. Let's solve this thing out. So what do we need here? Tangent of u is equal to some number. We get an inequality for u, and we're going to try to solve cosine of u over 2. So it's going to be needing a half angle formula for cosine in order to solve this one out. And in order to solve that half angle, we're going to need a reference angle for u. So that's where I'm going to start. Get a reference angle going for u. If I take a look at my inequality over here, u is in between pi over 2 and pi. That's the second quadrant. And that's backed up by the fact that the given tangent value is negative. So feel pretty solid about that. Let's go draw that shape. I'll start by giving myself coordinate axes. Then I'll come through and draw a triangle. Maybe start by turning that gray. Line it up a little bit better. All right, U is that angle right there. From the tangent equation, I know tangent is opposite over adjacent. So my opposite side should be square root of 39. My adjacent side should be 5. And I need to assign a negative somewhere. I'm in the second quadrant, so the negatives should go on the x side, the adjacent side. The x values are negative. The opposite sides being y are still positive in quadrant 2. So next up, I need to solve for the hypotenuse, call it c. So if I set up an equation real quick, Pythagorean theorem being the equation in question, I should get c squared is equal to 5 squared plus 39, or root 39 squared. That's going to look like 25 plus 39. Pretty sure that's 64. Meaning c itself is going to have to be the square root of 64, which is 8. Come over and fill that in. My hypotenuse is 8. Notice I didn't bother with a plus or minus this time. I know that I always assign positive values to the hypotenuse. The only time we'll deal with negative values on a reference triangle is when we're assigning them to the legs, either the opposite or the adjacent side. So I've got my reference triangle now, which means I can get the cosine of u, which I know is going to be important to the half angle problem. If I slide down here real quick and fill that in, cosine of u over 2 is equal to plus or minus the square root of 1 plus cosine u divided by 2. So now I've got my inside figured out. The part that I don't have figured out yet is what to do with that plus or minus on the outside. And in order to figure that bit out, I need to know where u over 2 is located. I know u is in the second quadrant, but I haven't yet found u over 2. Where is half of this angle? And since I've already drawn the reference triangle, I could probably eyeball it from here and say that half of that angle u would be about right there. Call that guy u over 2. Slide my label for u over so it's not running in the way. Half that angle looks like it's about here. Right, if I just cut it in half, I'd end up there, making me in the first quadrant, or putting that half angle into the first quadrant. But if I were to come at this with a more mathematical or formulaic approach rather than just eyeballing it, I'd come back to my inequality up here at the top of the screen, top right of the screen. U is in between pi over 2 and pi. If I want an inequality for u over 2, I should just multiply that whole thing by 1/2. Giving me u over 2 in the middle with pi over 2 on the right and pi over 4 on the left. So here I know, putting it all together, that u over 2 must be in between pi over 4 and pi over 2, which puts us in the first quadrant. So either way, I know I'm in quadrant number 1, and in quadrant 1, cosine values are positive. because all values are positive. So let's arrange that down here. I am looking at the positive square roots of 1 plus the cosine of u. I'm going back to u on the inside, going back to the blue angle. Everything I've done in blue is for the full angle u. Everything I've done in red is for the half angle, u over 2. Cosine of u is negative 5 over 8. All that's over 2. So notice the cosine on the inside of the square root, because I'm going with the blue angle, that one's negative. But on the outside, where I've got the red angle, cosine is positive because the red angle is in the first quadrant, but the blue angle is in the second quadrant. So just be careful with that. But from here, what's up next? I want to simplify that thing. I'm going to multiply top and bottom by 8 over 8 to get rid of an extra denominator. This is going to give me the square root of what are we looking at up top? That looks like 8 minus 5. 8 minus 5 all over 16. And if we simplify that, square root of 3 over 4. 8 minus 5 is 3. Square root of 16 is 4. And we're done. Well done with that problem. I think we've got another one to go, don't we? Yep, we sure do. All right, so let's solve this guy out. Finding the exact value of this tangent expression. So we've got to come back to looks like a difference formula for tangent. So I might start by noting that I'm going to be taking the sine inverse of some number, but the result of that is an angle. I'm going to call that angle alpha. Close enough. So what I'm looking at here is the tangent of alpha minus pi over 4. Both of those are angles. So I'm going to use a difference formula for tangent on alpha minus pi over 4. Going to my formula sheet, I know that looks like tangent of alpha minus tangent of pi over 4. All of that divided by 1 plus the tangent of alpha times the tangent of pi over 4. So again, all of that I just got from my formula sheet, which you get on the exam. You don't need to have any of that memorized. You can just go look at the formula sheet to get that value. Make a little bit more space here. So the next part, I don't yet have tangent of alpha, and I know that some value is going to go in there. I do know tangent of pi over 4, though. That's just 1. I'll divide that thing by 1 plus, again, an unknown tangent of alpha value, but that, again, is multiplied by 1. Tangent of pi over 4 is 1. So I just need to fill in those 2 blanks with the tangent of alpha. So that's why I've got to go do some math to figure out what that thing should be. And in order to do that, I'm going to want a reference triangle. So over here, give myself the coordinate axes again. I'm taking the sine inverse of a negative number. Sine inverse is only in quadrants 1 and 4 because it's the inverse function. It's only defined in those two. And it's negative, so it can't be in the first quadrant. Means I should sketch my reference triangle in the 4th quadrant. Looking at this guy right here. Just that, so it's a little bit better. And actually, try redrawing it again. Well, now my coordinate actually should have been over there. And because this is an inverse sine, I know that alpha is a negative value. It is this angle right there. It is on the inside of my triangle. Alpha is that guy. That. Right. Line it up a little better. There we are. Cool. So I've got my angle labeled. I've got to come in and fill in everything I know about this reference triangle. Sine is opposite over hypotenuse. So my opposite side is 11. My hypotenuse is 61. I'm in the fourth quadrant, so I should put a negative on my y values, meaning that negative should apply to the 11. And I have a missing side x. And I'm going to need the Pythagorean theorem to solve for. So I just fill some stuff in, Pythagorean theorem. I know x squared should be equal to 11. Oops, let's try again. X squared plus 11 squared is equal to 61 squared. There we go. So that means I've got x squared is equal to 61 squared, 3,721, minus 11 squared, which is 121. 3721 minus 121 is 3,600. So x squared is 3,600. I can take a square root of both sides. And the square root of 3,600 is going to be 60. So throw a plus or minus 60 up there. Since I am solving for a leg, one of the, the opposite or the adjacent sides, I should get a plus or minus when I look for that value. So then I just need to remind myself what quadrant I'm in. Currently in quadrant 4, and in quadrant 4, x values are positive. So my x value is positive 60. And then I can use all of that to go get the tangent of alpha, the tangent of that triangle. Tangent's opposite over adjacent, so we're looking at negative 11 over 60. And we can also check ourselves real quick. We know we're in the fourth quadrant, and in that fourth quadrant, x values ought to be negative. So last thing to do is just simplify this answer. Get it to look a little bit nicer than it does. So I have too many denominators. I'd like to get rid of some of them. So I'm going to come over here and multiply top and bottom by 60, just to get rid of that extra denominator. And doing so, just gonna make that a little bit bigger, bring it down some. Doing so is going to get me to negative 11 minus 60 up top, divided by 1 times 60 is 60, minus, yeah, that's still going to be minus 11 on bottom. If I multiply 11 over 60 by 1 by 60, I get just negative 11. It's negative 11 minus 60 over 60 minus 11. Last thing to do is to just simplify top and bottom. They're both integer values. Negative 11 minus 60 is negative 71. And 60 minus 11 is 49. Cool. So negative 71 over 49. And that's the whole practice exam. The very last page on here is that formula sheet. So again, if you're taking this exam in person in a recitation, so if you have one of the in-person recitations, the very last page is just going to be this formula sheet. It's the exact same one that I've got here on the practice exam. I've also posted it in an announcement on D2L. If you're in person, feel free to just rip this page off the back of the exam and then just have it in your workspace as you're going, so you don't have to always flip to the last page. You can leave it on if you want to, doesn't matter. If you do choose to rip it off, you do not need to turn it in when you submit your exam. You can keep this as a memento of our time together. And if you are in one of the online sections, you should have seen an announcement on D2L recommending that you print off the formula sheet that's been linked in that announcement. It'll also be provided for you digitally on the practice exam, but it'll be annoying to have to keep switching back between multiple pages or multiple tabs of that online exam. So it's probably easier to just print it off. But you do you. I'm not your dad. I don't need to tell you what to do. But anyway, yeah, that's the practice exam. So with all that said, if you're still watching this right before the exam, good luck on it. I believe in you. I'm sure you'll do great. And okay, bye, bye, bye.